The strongest acid has a hydrogen attached, the most electronegative. So we've talked about this already, but why are alcohols stronger acids than amines? Because oxygen is more electronegative. Okay. Which value? The value. Valence electrons. Valence electron is going to be the group number. Are you? Yeah, you'll have the periodic. So you just have to know. But any question, why are protonated alcohols stronger than protonated amines? Because oxygen is more electronegative. How does hybridization affect acidity? Well, we talked about the fact that electronegativity is increasing as S character is increasing. So when we are comparing carbons, the hybridization of the carbon is going to tell you which carbon is the strongest acid. And the carbon that is the strongest acid is the most electronegative carbon, the one that has the most S character. So an sp3 carbon is a really bad acid. It has a pKa of 60. An sp2 carbon is more electronegative than sp3. So it's a better acid and it has pKa of 40 to 45. But a sp carbon is a much better acid. In fact, it's a better acid than an amine. And with the percentage of S character, it's very electronegative and has pKa of 25. Size can affect pKa as we are going down a group. So we talked about size across a row and acidity across a row, or electronegativity across a row, is what we were talking about. So electronegativity across a row, we said as we go to the right side of the periodic table, the atom bonded to hydrogen is going to become a stronger acid. But what about for size? If an acid is something that has a weak bond to hydrogen, where are bonds getting weaker? Are they getting weaker as we go up a group or down a group? Down. The periodic trend in bond strength is that it decreases as you go down the group, so that as the size of an atom increases, it gets weaker bonds. That means that as size increases, if the bond that I have is to hydrogen, then I am becoming a stronger acid as I go down the group. Okay. So in Gen Chem 2, I always wonder this: should we teach you guys that acids are things with weak bonds to hydrogen, or do your professors teach you that an acid is something that has a weak bond to hydrogen and phrase it in that way? Do you think it would help, or would it just simply? An acid has a very weak bond to hydrogen. Bonds get weaker as you go down a group. So iodine in row 4 is a stronger acid than HF in row 1. Okay. And so what does that mean for base strength when you are going down or up a group? We would assume that chloride would be the strongest base, right? It's going to be more tricky. We'll talk about that in the later, because it turns out that something that is more polarizable can actually be a fairly good nucleophile. And how does polarizability increase? Because I think it's later. We're not going to worry about it right now. Okay. Some more pKa values is our next. All right, we're gonna get some pKa values, but they're already in my chart, so get that. Substituents affect the strength of an acid. So we're going to talk about molecules with identical functional groups for the acid proton, and how other atoms that are not part of that functional group can affect acidity of that functional group proton. So in this case, we're talking about carboxylic acid. How does what we call a substituent or an extra group affect the acidity of this functional group's proton? Okay, so we care about this hydrogen and how acidic it is. And we want to know, how does having a halogen bonded away from that hydrogen affect the acidity of the hydrogen? Do you think it makes it a stronger bond or a weaker bond to put a halogen somewhere else in the molecule? Weaker, because halogens are more electronegative. They're electron thieves. So when we bond bromine, chlorine, or fluorine to this carbon, we are taking electron density from that OH bond. What is going to make it, if you had to rank them from strongest acid to weakest acid, what would be more important? The size of the halogen or the electronegativity of the halogen? The electronegativity, because its ability to withdraw electrons is what's making the bond weak. Okay. So in this case, we have fluorine as a halogen, then that is going to be most acidic carboxylic acid. Okay. They put this question on the ACS exam every year. Every year. I don't know why they keep repeating it. They must think it's important. But every year you have to rank carboxylic acids bonded to different halogens and say which one is more acidic or which one is less acidic. Okay. And the process of the halogen withdrawing electrons has a fancy name, inductive electron withdrawal. And so if you see the term inductive electron withdrawal on your test, don't panic. Vocabulary is going to be really important in this class. Okay. Inductive electron withdrawal means you have an electronegative atom that is doing what it wants and stealing electrons. So that would be the definition. So if you're going to do a practice problem with me real quick, I have several molecules on the next slide for you to rank from strongest acid to weakest acid. You draw 5 pentagons, move room between them, and add other things. On the first pentagon, draw a bond to CH2 and from CH2 to OH. Then you can add carboxylic acid group together. So we're adding CH2OH to one and carboxylic acid group to the other. The other 4 should get a carboxylic acid. You know, do you think Cardette has a cover? Oh, hey! There it is. Okay, there it is. So we have 1 alcohol functional group and then carboxylic acid, carboxylic acid, carboxylic acid. But 3 of our acids also have halogen bonds. Which acid do you think is the strongest acid? Which letter? B? We have B is iodine, which is the least electronegative halogen. And what we care about here is electronegativity, okay? Because this atom is not bonded to the hydrogen. So those hydrogens all have relatively the same pKa until we add something that withdraws electron density. So in this case, we're not comparing size, but electronegativity. So this rule up here, across a row, compare electronegativity, down on size, down a group, compare size, not electronegativity. You need the note on, write a note on this slide. This rule only applies when you are talking about the atom that has a direct bond to the acid proton, okay? So for this rule, we're talking about the oxygen. The oxygen, 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 oxygen. But they're all oxygens. They all have the same size and the same electronegativity. The difference between the alcohol and the carboxylic acid is that we have 2 oxygens. So the fact that there are 2 makes it more electronegative, and then that's a stronger acid. Then when we add the halogen, that makes it even more electronegative and a stronger acid. So the most electronegative halogen, B, is the strongest acid. And after B, we're going to move to D, or B, and then E, and then D, and then C, and then A. So the going from strongest acid to weakest acid, it is B, E, C, E, 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 okay. B, E, E, C, E, E, D, C. Okay. What if I added one of the questions on the test? We we give you one molecule and we change the number of halogens bonded. Okay, so I have a molecule like this with one halogen bonded, then I have one with two, I have one with three, I have one with four, I have one with five. Which one is going to be the most acidic? The one with five. The more electronegative atoms present, the more acidic the proton. And then one other trend, you can compare the same molecule, and instead of changing the number or the identity of the halogen, change the distance the halogen has to the acid proton. What effect do you think distance has? Is electronegativity more effective when it's closer or further away? Closer. Okay. So the closer the more electronegative atom is to the acid, the more acidic the acid, or the lower the pKa. Yeah, that's the last trend that I have for you. The rest is some review on why carboxylic acids are more acidic than alcohols, a summary of the periodic trends, how hybridization affects acidity, how proximity and how electronegative the atom is and how electronegative the number of atoms are affects acidity and all of that. The only thing that is new that we're going to cover next is looking at some non-protic fluid acid. So that non-protic fluids with acid and basic will be on anything. But anything that I cover today, based on what we're going to go outside. Okay, free to go.